Oi lads, it's Danny here today, bringing you a new video. Actually, this is going to be the last part of the limit definition for a trig function. So today we're going to look at the limit definition of cotangent of x and why I is equal to negative cosecant squared of x. But before we begin, please drop a like and subscribe and let's get right into it then. So, like always, we're going to have to use the limit definition. We're going to apply this formula. So let's get to that right away. Cotan, we're going to basically replace cotan using the limit definition formula. As you can see, it's going to resemble something that looks like this. At this point on, what we're going to have to do is apply a trig identity, and we can rewrite cotan as cos divided by sine. And we're going to do that for both functions, so x plus h and just x basically, right? So it's going to resemble something that looks like this. At this point on, we're going to try to get a common denominator. So we're going to multiply sine of x to the left hand side to this fraction and sine of x plus h to the right hand fraction over here. And we're going to basically have a common denominator as well. So when we rewrite this, we can rewrite it as this, basically, right? So this here is the common denominator, and we can multiply 1 divided by h instead of having this division that looks like this. At this point, what you are going to notice is we could do something over here, and we could do something over here. So cos x plus h and sine x plus h can be rewritten using the additive trig identity. So I'm going to apply that, and we can expand it and it's going to resemble something that looks like this. Once you have this expanded, what you are gonna have to do is multiplying the sine of x over here and the cos of x over here. So we're basically gonna expand it, and once you do that, we're gonna have a numerator that looks like this. We can basically simplify this and cancel out the like terms. So if you look very closely and very carefully, especially over here, sine of x, cos of h could be basically, you could basically cancel this out because it's the same term, essentially. Very important. So we're going to cancel these terms out, and what you are really going to be left with is an expression that looks like this. Notice we got a sine of h and sine of h on both of these terms, so we can factor that sine of h right away. And what you are going to notice, as most of these trig proofs, is that we can factor out a sine of h divided by h term. And we all know when you take the limit as h approaches 0, sine of h divided by h, that's going to be equal to 1 as per the squeeze theorem. So this is just going to go to 1 over here. So really what we're really left with over here is this expression. And over here, sine squared of x plus cos squared of x, that's just basically equal to 1 according to trig identity. So in the numerator, we're just going to be left with negative 1. And at this point on, what we're going to have to do, lads, is apply h going to 0, to this limit. And once you do that, you're going to have an expression that resembles something that looks like this. So really what we have here is negative 1 divided by sine squared of x, and that can be rewritten as negative cosecant squared of x. And this is why cotan is equal to negative cosecant squared of x. I hope you all enjoyed this video. If this video has helped you lot, please drop a like and subscribe, and I'll see you lot later. Bye.